Hello, everyone. Welcome to the second session in Columbus McKinnon's Safe and Sound speaker series. I'm Megan Voss, the marketing manager here at Columbus McKinnon. Safe and Sound Week is led by OSHA, and it's a nationwide event held each August. It's designed to recognize the successes of workplace health and safety programs and offer information and ideas on how to keep America's workers safe. So Columbus McKinnon is recognizing that effort with this speaker series on safety. Don't miss the rest of our sessions every day this week at 12 Eastern, 11 a.m. Central. Wednesday session is all about safety in harsh environments. On Thursday, we will discuss safety and crane controls. And then we'll wrap up Friday with a session on safety and entertainment rigging. Check the chat for a link to the registration page to sign up for any or all of the upcoming sessions. We will also be recording each session and posting on our website. I'm so glad you could join us today for our session on automation. We will cover what Industry 4.0 means for safety in your industry and at your facility, how automation can make you more safe and more profitable, and how to identify and address high-risk areas. We're going to chat today for about 30 minutes, and then we'll open it up for questions from you, our audience, at the end. So you can submit your question into the GoToWebinar's questions pane at any time, and we look forward to hearing your thoughts and questions. I'm joined today by Peter Stipan and Jim Kluck. Peter is the Global Director for Columbus McKinnon's Automation Division, and he's recognized for his passion and ability in global process improvement, automation, and leadership. Peter's expertise stems from over 30 years of experience in overhead cranes, starting as a marine and industrial technician to leading development engineering in inverter drive design and advanced automation applications. Peter's published books on high temperature semiconductors and electronic packaging, reliability, and failure analysis, and he's also a Six Sigma Black Belt certified. Jim Kluck is our Global Product Manager for the Columbus McKinnon Automation Division, and he leads the development of our intelligent crane and hoist solutions. He combines an engineering mindset with over 20 years of marketing and field experience in a variety of vertical industries. So without further ado, let's get our conversation started. Peter and Jim, thanks for being with us today. To start off, I'd like to ask you, what's the impact of Industry 4.0 on safety and productivity in a manufacturing facility?
Thank you, Megan. IIoT 4.0, or the Industry Internet of Things, is the fourth age of the Industrial Revolution. Why is this important? Well, to improve safety, uptime, and productivity in manufacturing facilities, improved communications is essential. This is done by connecting various internal processes throughout production by placing sensors on critical points to gather data, and then use the analytics to predict and prevent failures from occurring. That also impacts the uptime factor.
Yeah, Peter, as we gather data and we look at adding additional sensors throughout factories and grabbing that data and turning it into useful information for people, automation is a key convergence for information services and technology with operational technology. So it's the combining of taking data and sensors and actuators and moving equipment and bringing it all together, not just in communicating, but connecting. And to address safety at a high level, we need to keep people safe in the harshest of conditions to prevent injuries. Automating overhead bridge cranes or below the hook processes has the advantage of keeping people out of harm's way.
So, Jim, tell me a little bit more about the sensors that gather data that Peter mentioned. What do they do?
So there's a number of different sensors that people are starting to use that you can use in your facilities as well. Well, there's sensors that measure specific things like heat or temperature or distance. There's a number of different sensors that are out there in the market space, and they've really come down in price, and there's a lot more. And these sensors all have the capability to communicate to the outside world. They're no longer just providing an analog or a digital signal. They're able to provide information about what's going on and helping customers, again, understand when to do maintenance or when to do service, or when things are going wrong. Distances, heat, where things are moving so we can keep track of them are all part of the sensor's responsibility. You see sensors in your everyday life like your car backing up and giving you an alert, right? We've all got these cars nowadays that have got additional sensors and capabilities built into them. So we're using sensors like that to gather data. Key step is to take that information and make it useful. These sensors are used in our industry to provide data on the production floor, gather the information from sensors, and then create meaningful action from it.
And as we mentioned, Jim, visibility is key. So the sensors are connected, and we need to communicate the information from those. One example is an overloaded crane. Okay, so you can put a load sensor or load cell on your crane. On your hook, you can put a display up above your bridge crane so people can see it. They can understand what the load is. The operator now knows exactly what they're lifting. One other example, Jim, is what we're recommending for everyone to do out there is preventing an off-center picks. So you don't want to pick up something and have it swing. You also want to have the safety in the system built in.
Well, thanks, Peter. Can you guys dive a little deeper into how this automation technology, these sensors and things, can improve safety? So, for example, what are the most common risks with lifting applications?
Yeah, that's a big concern when we look at overhead lifting applications. When you're lifting a load, as you can see here in this picture, it's rather large as far as its physical size, but it also weighs a lot. And as you start to lift that off the ground and you move it from place to place, there's a lot of things that come in the pathway, whether it's workers, the operator that's moving it, equipment, the building and the structure itself, especially if you have to go over the top of things. There's a lot that needs to be taken into account. So when lifting something like this, as you can see in the picture, if those chains aren't exactly straight when lifting up, if there's a little bit off center, that can lead to a dangerous situation. As soon as the operator lifts that off the ground and it comes away from that contact with the ground and that friction, that load could swing, and then it could, swing into somebody or something, creating a hazardous situation. So when looking at examples like this, workers could be at risk, the equipment, the overhead lifting equipment could be at risk. So we want to provide equipment that's going to help the operator do its job more safely. If this load is off by a foot or so, and you've got a 40-foot long rope from the top of the crane to the plant floor, that could swing up to 4 feet. Equipment, operators, personnel, and lifting equipment itself could be damaged. We want to try and avoid these hazardous situations.
That's a good point, Jim. It is quite hazardous. So our whole goal is to prevent these hazards and to make a more safe environment. One other example, we were at a customer site and they had a jib crane, not an overhead bridge crane, but a jib crane that was overloaded, and it actually collapsed, okay, nearly hitting some workers. Their first reaction was, when they're putting this in place, is can we get a longer controller tether for their controller? And we're saying, well, what about, let's recommend using a radio remote control. Okay, this way an operator can move to a safer position during the jib crane operation, farther away from any potential hazards, providing a clear line of sight for the operator.
So, guys, can you tell me, how could that unsafe situation have been prevented?
So first, looking at practices that people are using, they were doing something that was unsafe in the first place. So there could be some training that needs to be involved, but then also looking at, is there technology or solutions out there that could be in place to help the operator understand how much they're lifting and where they're lifting things. So for a solution like this, when they're lifting something, those overhead cranes and those hoists are rated for a certain amount of load that they can lift. So having something like a load cell, which measures the weight of what they're lifting, and then having a display that actually displays in pounds or tons how much they're actually lifting, to know, am I over the limit of the crane and the hoist? That's the first thing we can do, is provide a sensor that measures, again, what's going on, and then display that information to the operator so they can make a decision. Should I continue with this lift, or is this too much? Do I need to go and find some way of moving this without using this overhead crane?
So can you tell me how do you add this automation technology onto your operation? Can you add it to your existing operation, or does it have to be during a new build?
No, Megan, it can be done in new installations as well as retrofits. You know, a lot of the times these cranes or hoists, the steel lasts a long time. The equipment can last a long time if they're well maintained. So automation and adding additional sensors and equipment, especially when it revolves around safety, again, we strive to make sure that it can be added at any point. So not only in new situations, but can be in retrofits. It should be easily adapted or added on. Custom engineered systems or our off-the-shelf products can be added at any time. We also take into account how is somebody going to accomplish that in a new or retrofit situation. Do they have to run new wiring or new controls? So we want to make it easy for them to set up and do, whether we do wireless systems, as we see the adoption of more and more wireless connectivity and people willing to connect and use wireless communication for seeing data and getting information. That makes a big advantage for doing retrofits. So being able to use intuitive user interfaces that can be used right on the plant floor, and using technology that people are familiar with. Their mobile products, their smartphones, their tablets are all things that people use on a daily basis that can help them now interact with these systems that are being implemented. Again, trying to make them designed to be easier to install and use, not having to have the automation experience in the background or PLC programming experience or years of engineering work. We want to try and make them easy, intuitive, not only to set up and commission, but to maintain throughout the life cycle, so that a technician or electrician or just an operator at the plant floor can interact with them, get information on what they're doing with their lifts and movements, as well as help them with future selections when it comes to new products.
Going for the overall safety, right? So Megan, I can give you another example. We've had customers in aluminum production and in the marine industry, okay, on a port, where they have issues with what's called an over and under crane. So you actually have two bridge cranes, one goes over the other one, okay? And they do this for special applications within the processing of aluminum, or in the example of shipbuilding, they have a hull of a ship and they have the hoist connected, the two bridges go over and the hull can be flipped over so they can do some construction on the reverse side of the hull, right? Well, when they're not using these, when they're not in this operation, one crane could go and hit the other one because it's got the hoist hanging from it. So what we've put in place and what we recommend to all our users is to put in a collision avoidance system, an automated system that tells you, hey, you better stop or slow down if you're going to hit something. We have our new IntelliProtect system, can be built in to prevent the safety hazard. And having these types of systems built in the automated way, you can drive even higher efficiency and safety of their current systems. And with these better results, seeing significant return on investment, safety becomes the leading indicator.
So Peter, can you tell me, how do you approach safety when you're working with a customer looking to solve a problem with this automation technology?
Megan, thanks. This is what we're all about here today, this morning. Too often, the focus people have is on productivity, okay? But by promoting safety, you will improve uptime and productivity. Knowing and understanding the customer's needs and then having the trust in place to solve their problems for them is crucial. Detecting a problem is one thing, but preventing it is another. So we start with data from our customers. Why is safety important to you? How can we help you improve your safety, operational safety? What is the biggest safety issue you're facing? So by talking through these processes and asking these types of questions, we're able to identify the right solution to solve the problem, and everyone out there can do the same thing.
Well, so Peter, how does that affect uptime and productivity then?
Affecting uptime and productivity. Okay, so let's answer that first by saying the safer you operate, the more profitable you will be. I'm just going to repeat that for everybody out there. The safer you operate, the more profitable you will be. Do not compromise safety with the push to get more product out the door. That's the wrong approach. Treat safety first, which improves your uptime and productivity. By building safety into the operation, you prevent accidents that cause unscheduled downtime while increasing the throughput. Ultimately, you should address safety first because employee safety should be the #1 priority. You want people to go home the same way they came to work, right? You address safety first, and then everything else will come into place.
Yeah, and when we think about safety and solutions, there's a number of different ways to address things, whether it's a small system to a large system. If you've got a plant floor that's being continually updated and you've got a lot of moving parts and pieces, we offer different opportunities for providing safe solutions for those types of customers. Whereas if you have something where your automation or your plant floor is really not changing all that much, again, there's opportunities there as well. Things like IntelliProtect, our no-fly zone. As you can see here, looking at a plant floor, you've got this office structure that's in the plant floor, and you want to avoid making sure that the operator doesn't accidentally run into it with a piece of equipment or the crane itself, just because there's probably people working in this office building and they're not paying attention to what's going on in the crane. So they're in a situation where they're doing their jobs, the operator has to do their jobs. And so what we do with this no-fly zone package is we create a protective barrier around this no-fly zone. So it's a specific area of the plant floor where we don't want the crane to operate. And then we build layers outside of that, a stop zone and a slowdown zone, so that as the crane, if it were to get close to it, it would provide identification to the operator. Hey, you're within the slowdown zone, and start slowing the crane down. Hey, you're in the stop zone. We need to stop the crane. And if you really got all the way into the protected area, stop and fault out and make sure it can't move any further until somebody recognizes it and makes the adjustments and figures out, how do we make the zone better? Do we need to increase the width of the specific slowdown or stop zones? But this type of technology can not only be used for installations like this where you've got an office structure, but let's say you had operators working on the plant floor, or if you had equipment that was sensitive or high value, stock of materials that you wanted to avoid, things like that. You can use this type of system. One other example is where they have robot arms, or if they have equipment that goes up and down within the facility. This type of system can also interact with other systems and make sure that if something is up and is it potentially in the way, we want to make sure we don't have a collision. So identifying that, let's say for instance, a robot arm or a piece of equipment is all the way up at the top, it can provide a signal to the system and say, hey, I'm operating now, you can't come over this area just because we're operating. Wait until that operator then sends the signal back and says, hey, we're in the down position, you can go over the top.
Thanks, Jim. I want to go back and touch on something Peter said earlier about trust. So can you elaborate a little bit more about the importance of trust when working with your customers?
I sure can, Megan. As Jim mentioned, no-fly zone. The customer trusts that it's going to do as it said it's going to do. So with an automation and with safety, we're like, how do you get that without having trust? So we believe success comes in 2 factors. First, understanding the customer, and then secondly, trust. When you understand what's required by the customer to meet the customer's expectations, the quickest way to build trust and to resolve this is to work to solve problems together, right? So we trust in each other to provide the best and safe solution. Trust in the experience and expertise in the automation team, using the right data for the communication, more importantly, the connectivity aspects. And I know that these are integral factors in ensuring overall safety within the organization.
Yeah, and with the Industry 4.0, as we begin to connect and we add sensors, and people start to get familiar with it and add the capability of then taking that data and turning it into meaningful information and acting upon it, they're becoming more efficient. They're getting more useful information to help them in the decision-making process. And now as we go forward, as customers and people start to adapt and use Industry 4.0 capabilities, we'll begin to look to Industry 5.0, where we start to see the resurgence of the people in the workspace coming back and working with the equipment. How do we improve that overall experience? How do we leverage the two together, whether it's the sensors and 4.0 bringing in data and information to then having the mindset of the worker back at the controls and figuring out how to do things, maneuver things, and work together so that, when you have people and machinery working together, using the advanced technologies to benefit not only the workers and improving safety on the job, but helping with production and making sure that, again, you're getting your products out the door.
Exactly.
Yeah. So I know both of you have years and years of experience and have gotten out and seen, quite a few examples and processes in your careers. So can you share some real life examples with us about where you've seen safety and technology work together out in the field?
Sure, go ahead, Jim.
Sure. I think about, like I said, the one area we talked about was the use of personal electronic devices and giving access to information and data. That's a big step. If you think about a lot of the cranes and the hoists, they're up 20, 30, 40, 50, 60 feet in the air. So being able to take and put the person outside of that space at the plant floor is meaningful. It's helpful. They don't have to climb up on the crane itself. They don't have to get a scissors lift or something like that and safety harnesses. They can get information from the plant floor. Also, giving them data and diagnostics outside of the electrical cabinet. So one area of focus is electrical safety, where if we can provide data outside of the cabinet, they don't have to worry about arc flash and going inside cabinets that have high voltage that is exposed. So looking at arc flash and not having to climb, there's a number of different products and solutions that are out there to provide safety to those types of areas.
Right, there's also examples. I mean, you can walk into a facility and you can just see certain aspects of the operation that just are dangerous. One is a very hot metal pouring, right? You don't want people to be near that operation. So if you can operate something automatically or push a button so it'll move the crane and the hot metal on its own without having people in the way, it's a much safer process. Also, you can see a lot of fork trucks in factories that are picking up very heavy loads, moving them to another part of the process. You won't need these fork trucks anymore if you're automating it from an overhead crane. Everything automatically moved, loaded. It makes it a much safer environment.
Yeah, one example is we had a customer who was moving large transformers. And not only when it comes to that type of equipment, when you're looking at size, but there's a lot of equipment out there that's being moved that's very large in size, and it may be difficult to see completely around it, and they may use an additional operator to help guide things. But with safety systems that can do measurements and understand load sizes and where things can operate or not operate, that just overall makes the system overall better by being able to understand I've got this hook, and below that hook is something that's 40 feet in length. It can then understand I need to be 40 feet plus the safe distance away from other equipment. So, there was an instance where somebody was moving a large transformer and it collided with a wall as they were moving something around. So, those are the types of things where we can provide some solutions to help them.
Another example, Megan, is in the aerospace industry. You're building these large wings. So you're sitting in an airplane and you look out the window and you see these large wings, right? So when they build them, how do they move them? So you may have one section of the wings higher than another. It can be very long. So they'll use multiple hoists to move these, multiple bridge cranes. And manually, they have people trying to operate it and say, okay, go up a little bit, go up a little bit. You can, with our bridge synchronization, you can sync several bridges to move simultaneously, all by automated control. Hoist sync, so you can pick up something this way and they can move it completely to where it needs to go. This type of thing, it's not really safe to do manually. but it's extremely safe to do automatically.
Yeah, there's so many examples that we see on a daily basis with one where energy facility where again they've got trucks coming in and out all day long and being able to sense them at different times because it's not a scheduled thing. It's not a widget that's coming down an assembly line. It's whenever the truck happens to show up. So whether you're using light curtains or vision systems or radar detection, there's a lot of different things that are out there that help to detect things and provide them, especially like if you think about cameras and how much they've improved and the information that can be grabbed from a vision system and brought back, all to make things safer. Or you think about an automotive plant where you think about all the things that are taking place in an automotive plant, whether you have robots moving, forklifts, operators assembling things, an assembly line that's continuously moving. They're looking at getting that next vehicle out the door. They're judged on, can we get a vehicle out every minute or less than every minute. So they got to have a lot of systems that are operating and coordination that's taking place. So one area that it can be addressed is the automotive area where they do stamping of metal, where they have large die sets that actually form the metal for fenders or a car hood or trunk, things like that. They have die sets that are very large that press this metal, and moving them from one location to the next, again, you're moving big pieces of equipment. If you could use a fully automated system to do that and put a fence around that area, that provides a lot of safety and capability to be able to do that without having to worry about, is there an operator or not? So these die gripper handling sets or fully automated systems can pick up the necessary parts, move them from one location to the next, all based on an operator telling them what's next in the system or what's coming down the line.
With a crucial thing with all this, Megan, and everyone on that's listening, is these examples of automation systems have improved the safety of the operation. So that's why we're here today.
Yep, safety is priority number one. Thanks guys for sharing all those examples with us. So I think it's time, let's open it up for some questions from our audience now. So just a reminder, you can type your questions into the questions pane in the GoToWebinar system, and Jim and Peter will be happy to answer them for you. So let's take a look here at our first question. Okay, so this question is, someone's asking, how do they get buy-in to implement automation from within their organization?
Well, Jim and I can answer this, Jim, because we always say, what's up? SUP, it's your safety, uptime, and automation, right? Safety, uptime, and productivity with automation. So let's look at the processes and have you look at the processes with return on investment mindset. Where is your bottleneck? Where is the safety the greatest concern? As we, when we go in, we can see this, we can talk, we can listen and understand and build that trust with our customer. What injury records do you have that indicate an unsafe area? So let's identify the risks, the near misses, and the equipment damages. These really add up. According to the National Safety Council, Megan, the financial cost for a death on a job is $1.19 million. So we provided and built a prototype solution, which became our IntelliLift for off-center pick. Within 2 months, presented it to a customer to show that when they pick up this product, it does not swing. No matter what they did with the controller, they cannot make it swing. This technology is available to everyone from Columbus McKinnon.
Yeah, and when you think about implementation of automation, for safety as well as for improving uptime or productivity, one area that people can quickly look at is their downtime. What does their downtime cost you in production loss? People having to chase down spare parts or look at manuals or have the right people at the facility who can troubleshoot and repair something. So if you think about a process that maybe is making something that's $400 a minute and you're down for several hours or a week, that could add up to $4 million in a week being down. So investing in some automation, whether it's specifically addressing safety concerns and making it the area safer for the operators and the equipment, or you're addressing uptime by getting visibility in how the equipment is being used, how much it's being utilized for specific functionality, or whether it's, like I said, productivity. How many widgets per hour am I manufacturing or moving? The investment could be relatively small compared to the overall cost of that downtime incident, and the payback could be, in a short period of time to months.
Thanks, Jim and Peter. So our next question is a scenario someone's describing. So they have a situation where they need to move a 10-ton crane down a path with a lot of obstacles, including employee workspaces. How would they address that?
That's quite a common situation for us, and that's where we live and breathe every day, is helping our customers with those types of high value problems where they're moving something and they've got obstacles to avoid, whether it's people, personnel, and they've got large pieces of equipment that they're moving. So the capability is there where automation can bring multiple solutions to your application. The addition of sensors, whether it be, for measuring equipment or heat or vibration, or just understanding where equipment is, can be joined together to provide, these solutions and measure distances where things are and where things need to be avoided and where things can move to. So if they have a point to point, or if they're going from point A to B to C to D, etc., they're going to need something that can help them lift it safely and then move it and transition it to all those different locations. Not only, like I said, with the lifting part of it and avoiding certain obstacles and finding a specific pathway, but also once it's lifted, using an anti-sway function. So as you're maneuvering things and you're slowing down and stopping and starting, you don't want that sway to occur where the load can start to swing back and forth. Using an anti-sway functionality built into our products to help keep that from occurring allows the operator to move quickly through those areas and transition from one point to the next. From small chain hoists all the way up to larger 100-ton overhead cranes, there are many different areas of safety that can be addressed, from electrical and mechanical, but also, like I said, as part of the movement of the operation as well.
Now, Jimmy said you can actually walk into the facility and see people moving a large object around things manually, and they have to have horns or lights or systems that are saying, "Hey, get out of the way!" And people are trying to move out. Where if it's automated, everyone understands it's a press of a button, removes it, and it avoids all people, and it is more safe.
Thanks, guys. Our next question, someone would like to know, do you deal with entertainment automation?
Yes, we do. The entertainment business is not what it used to be because of COVID, as you know, but we've had instances where you lift up stages and people are there to hold the lights, and the hoists and lifts are all involved with that. When they have 4 or 5 people saying, "Okay, go to the right, go to the left," they're trying to get this thing lifted to make it even across the stage. We completely automate that by having, I think, one instances we had 38 hoists synced at the same time. So you didn't have anybody operate them. You hook up your system, you press a button, and it just lifted the entire system automatically. That's one example.
Thanks, Peter. So the next question is about what's the different types of load cells used today by different manufacturers like Columbus McKinnon? Is Bluetooth a viable option now? What are other wireless options like radio frequency transmission? And are load cells wired as a default? So a couple questions in one there.
So yeah, there's a number of different types of load cells out there that we can use. So whether it's like a strain gauge or some other type, they communicate in different ways. And really, we want to address the installation and the environment that they're being installed in. So if you're using a load cell, it can be tied back into a VFD, a variable frequency drive, or it can be tied into a PLC or a controller to measure what's going on. Bluetooth communication, some people are using that more and more. It just depends on the proximity to where you're at, as well as the other things that are in the environment. Electrical noise you have to pay attention to, line of sight, whether there's walls in the way, things like that. So we're looking at not only, like I said, Bluetooth, but wireless, so Wi-Fi communication, as well as the different radios that we have for like our belly boxes that use wireless communication as a protocol. So they're all improving. We're all looking for not only the communication aspect of it, but also the safety. We want to make sure that that data transmission is safe and secure. We don't want somebody to be able to get into it or be able to cause it to move without the operator knowing, for instance.
And Jim, to your point too, these are options. So we have to understand what they are with the customer. So some customers may prefer one over the other. So we are offering them, right? Also within our IntelliLift, we have 100% snag detection. So if someone's going to lift it, they may be concentrating on the load itself, but when they take it, when they place it down and they unhook things, maybe they didn't unhook one. And as they go to move the crane, this heavy object, 5, 10 tons, whatever it is, starts to move. No. This product that we do for safety is built in. So that's, to your point, we're looking at the options, what's required by the customer, and we build these in our systems for safety.
Thanks, guys. Our next question here, is the term interlock still used in automation systems?
Yeah.
Yes.
So yeah, I mean, interlocks are, again, a big thing, as well as, so if you think about where the operator is, or other systems that tie together, so looking at whether we have safety like gates and light curtains or e-stops or all that stuff that's tied into it, to make sure the system is continuously looking, am I okay? Is there an operator in the way? Has something been broken as far as a fence or a gate? Yeah, we're still looking at different objects tying in and different sensors tying in to make sure not only is it, being safe to move, but is there something that happened or changed that we need to look at the state of something and say, okay, we need to shut down and stop the process and tell somebody or notify them that, an interlock has been changed for some reason or another.
We also use maybe I'll even say like a belt and suspenders approach. So if you have a mechanical interlock, maybe you have some type of electronic vision system or laser detection that also says, hey, has this thing been compromised or not? So we work with the customer to design those into the systems.
Yeah, we want to make sure, again, in all those instances where we identify an issue, we fail safe or we stop safe, we take the best approach to making sure that we stop and address the situation.
Thanks. So our next question is kind of a two-parter about wireless controls. So first question is, part of it is, do you recommend or require that the wireless control have restricted range, so the operator must be in visual distance of moving equipment? And two, do you require that the wireless is in full auto stop of equipment if communication is lost to the controller?
So yes, so the first part of that is being within a certain range of the wireless communication. Yes, it's critical to be within sight of the operating equipment. A lot of the wireless connectivity that we're looking at is around the data and diagnostics and information. And when it comes to the control of it, so being able to start and stop and move equipment, that's where we really rely then on our radio systems that have been put in place. Just because that's proven technology and people have been using it for a long time. As we get further into different areas of wireless communication, things may change, but for the wireless connectivity and the programming and the setup that we're talking about, that's really around commissioning, diagnostics, maintenance versus actually controlling, starting and stopping. So yes, we'd like them, even with that, when they're looking at information and monitoring it, it's still within a specific distance, just because that's some of the limitation around wireless technology, always being in line of sight so they can see what they're doing. And what was the second part I think you mentioned, Megan, was that?
The second part was, do you require that the wireless is full auto stop of equipment?
That's correct.
If it is lost to the controller?
Yeah, so again, we're not, even if we're looking at the wireless systems that we're talking about, if there's a loss of communication, we always want to make sure that it fails or it stops communicating in a safe state. We don't want something to continue on or operate when there's no communication. So that's definitely something that we always build into our systems and design. And is if there is something that's communicating with one of our Intel crane products and there's a loss of signal, if it's just monitoring, again, it fails safe so that the crane isn't affected. But if there is some control aspect, making sure that it fails safe and stops so operation doesn't continue.
Thanks. So next question is, would you mind describing fail-safe mechanisms that you commonly see and how they work? For example, hoist brake engaged when not receiving current.
That's a good question. Jim, do you know how to answer that one? Fail safe?
So again, we're talking about again when operating, making sure that if there's a loss of control that we fail safe, right? So if there's things like on our belly box, if you're controlling a hoist motion or a bridge or trolley motion, that signal has to be continuously there. If that signal is lost for some reason or nothing or reason, the system will actually shut off. So the levers and the paddles and the designs of the controls on the radio are such that the operator has to be continuously pushing a button in order for movement to occur. If it doesn't, then the signal will tell the control to stop. But if the signal is lost altogether, then it's told, hey, something's wrong here. Stop all motions and fault out and provide a signal that something needs to be addressed.
We also offer options for our customers for products that you can have an automated radio controlled unit, or you can have a completely tethered unit. So based on the environment, maybe there's some sensitive communication signals within a military application or aerospace application, or you have an environment that the communication is not as readily available to certain systems. That's why we look at the options we have. We work with the customer to design the systems in place that work the best for them.
Right.
Thanks, guys. Okay, so next question. Do you offer built-in load weight detection without a separate load cell? For example, if I'm using a spreader beam under the hook load cell such that that the system understands the true load.
So we do have the capability within our variable frequency drives to understand how much load is being lifted. So it's not as accurate as a load cell would be right on the equipment itself, but it is accurate enough to determine, am I within the specs of what's being been designed. So the variable frequency drive is looking at the motor and how much torque is being used to lift something. Based on that, it understands that this size motor and this size drive is used on this size crane and hoist. From that, it can figure out, based on a percentage of that torque, how much am I actually lifting. So there's still, again, that capability built into our products, or like I said, going to external load sensors.
And just a comment on the automation aspect. When you talk about a process that's really well developed, those are the best to automate because they already know they're good. But in these particular lists with spreader beams or etc., they're unique, so they really need to be understood, and that's where we add our application expertise and support 24/7, 365 days a year.
Thanks. Our next question, how about biometric controls for bypassing safety features? Do you offer a solution that only allows approved users to bypass safety situations?
Yes, so it's really based on customer request, but we have looked at beyond a basic key switch, looking at like RFID or a badge system or biometric sensors. So there's a number of them that are out there in the market space that can be used. It's really then just picking one out that's specific for the customer's needs and implementing it into an automation system. A lot of our automation systems come from the customer's opportunity, what they're looking to solve, and what they need implemented. So we go through a process of sitting down with the customer, understanding all their needs, and then designing a system to meet those needs, whether it's automation, safety, tying in different pieces of equipment. Again, we'll design an automation solution engineered for their specific needs.
Thanks. So the next question is back to the topic of entertainment again, well, or in general. But when using wireless communications, do you take account other wireless systems within the facility? For example, in entertainment, it uses many wireless lights and microphones. Do all those signals complicate wireless automation communications?
I'm sure they do, and we do. There's a lot of things to understand in that with wireless and radio controls. So we do look at the specifications for the customers. The most important thing for us is to get a specification. We don't come in there and say, hey, use this, or say, hey, what works in this application. Elaborate on that?
Yeah, so I'll kind of address two areas. When doing a site survey, this is part of an area where we'd like to have addressed. When somebody's looking at doing something in a specific location, we'd like to have a site survey that goes out and says, what are all the wireless communication devices that are out there? And then making a list of them so we can address and understand, what frequencies are they operating? What, wireless systems out there are they operating on, whether it's 2.4 or 5 gigahertz, things like that. So we want to understand what is all being shared in that specific space. There's also, again, regulatory bodies that are also looking at communications, whether it's like FCC, and making sure that, again, as you're communicating on specific wireless channels and frequencies, you can't operate or interact with other pieces of equipment. So that's why when we're designing systems and we are looking at wireless, we also do testing, and we also specifically test the specific regulations to make sure that we adhere to what's going on and the guidelines that are being provided.
Well, thanks, guys. Well, we're getting close to our time being up, so I'm going to end with one last question here that I think is great. What's a concept in automation that you wish more people were aware of?
Right, Peter.
Yeah, there's one concept we wish they were aware of. I do know that there's a lot of people out there that are picking up large, heavy pieces of equipment, be it a die gripper, or be it a paper roll, or aluminum ingots, or steel coils. And when those get into an operation where it's manual, those things swing. And you can talk to operators on the floor, and they'll say, wow, someone almost got hurt. That, those are preventable. These are preventable. And within safety, our IntelliLift is just, like I said, just does that aspect of picking up a load and not having it swing at all. I wish everybody knew that was available. You can go to a factory today and walk in there, watch someone pick up a load, and watch it move. That's not safe. And with our product, it just goes straight up. So it is available to everyone.
And I think that's the message is, the cost of sensors is small in comparison to the damage that can occur or the injuries that can take place. And really that's where we focus, is trying to bring automation and safety solutions to the entire market space. We wanted to provide simple, easy to use solutions that could be implemented for everybody, and not somebody that just got the large capital budgets. We want to provide safety, whether it's a 5-ton crane that's moving a couple of control panels every couple hours, to somebody that's using a large crane in a process application.
Just as a quick note, I mean, if you're trying to center a load on a dock with fog, with bright sunlight, the laser is not going to work for you. So we know this, and this was told to us by a customer who says, hey, I need help with this. So our system doesn't use a laser for the off-center pick. Those are key things to understand what the customer wants, build the trust to solve their problem together.
Well, thanks very much, guys, for all of sharing your expertise with us today. And thanks to everyone on the call who participated. We really appreciate you joining with us today. A recording of this session can be found on our website shortly. There's a link in the chat that's coming up now and the full video will be up shortly. I want to again thank everyone for being with us today. I hope you join us for the rest of our Safe and Sound series, and enjoy the rest of your day.
Great. Thanks, Megan.
Thank you all.
Thank you, everybody. Have a great automation day.